stage is yours.
The stage is mine, right? Okay. Well, thank you for being here on Sunday, 10 a.m. Usually people actually, eat breakfast or stay at least at home on Sunday at 10 a.m. morning. So thank you for being here, and it's a pleasure for me to have a possibility to talk here in Kharkiv. It's actually my first time here in Ukraine. So, well, yeah. Before actually I go to the Jupyter notebook, let me just say just a few words about myself. Just to be clear, I know most of you are actually JavaScript developers, I guess so, because we are on a JavaScript conference, right? I used to be a JavaScript developer when the web pages were built using tables. Remember that? It's late 90s, beginning of the 2000s. This is when actually I started to do some JavaScript, and then I moved to machine learning. I started machine learning before it was so popular. Today I will actually talk about machine learning, combining it with JavaScript. Just a few words about my background. I'm working for about 10, 15 years in machine learning. I have a PhD in computer science and machine learning. I did many things about machine learning stuff. The recent thing actually, I have developed some algorithms for skin cancer detection during my PhD. And now actually I have my own company, Kolite, which is actually, it's in Poland. I'm originally Polish, working for different companies in data science as well. Analyzing data like data from the sensors from the car for autonomous driving, for example, and so on. So this is what I'm doing. I hope it will work. Anyone used before Jupyter notebooks? I know you're a JavaScript developer, so you are not used to. But in machine learning, it's something that is very common. Here we go. A Jupyter notebook, and there is an addition for JavaScript. Actually, behind it, you have a Node.js. What I would talk about today is actually just 4 points. I will just give you an introduction to machine learning, then I will go through some data cleanup, data preparation, and then I will show you scikit. Generally speaking, I will show you how actually machine learning is currently working with JavaScript. Are we in the same shape like Python, or are we still far, or what's actually, how does it work in JavaScript? You can try it out at home. Yeah. I'm not sure if it's my laptop or if it's a cable. It's mine. It's not my fault. Okay. So yeah, I'm not sure if is it fine with you, or should I make the size bigger? It's fine. Okay. Cool. Yeah. When it's yeah, exactly. So you are a JavaScript developer, so probably you know Docker, right? Cool. So the link that you don't see here is a link. It's a link to an image that I have prepared for you regarding. It's a Docker image. I know. Maybe. Okay. I will just talk. So I prepared that image for you on Docker Hub regarding with all the setup, because actually setting up Jupyter with it worked on my last presentation. Yeah. So I prepared for you an image with Jupyter, with Node.js, with all the libraries on the image, so you don't need to set up anything. Just download the image, run the container, and you are done. So here's the link there, and also the notebooks. You can also get it on GitHub. Don't worry, you can take photos. You can also grab a business card from mine after the speech, so I can share it with you, or I can talk with the organizers to share with everyone who attend my speech. So that's it. So let's talk about machine learning. Here we go. I know you're a JavaScript developer, so you're used to have this fancy, nice web presentations, and I'm coming here with some, looks like an old school tool, but it's not really old school, it's quite new actually. Let's talk about machine learning. So machine learning, it's a buzzword, right? Machine learning, artificial intelligence, big data, IoT, blockchain. It's all buzzwords, right? I was on a conference in May this year in Berlin. It's called Race of AI, and we had a stand there. And at the end of the conference, one of the directors from a company from Silicon Valley, I can't say the name, came to me and actually said, we talk about business, and then after that, he said, well, once actually a company came to us saying, okay, here you have $2 million, and please develop our machine learning solution for our problem. Okay, so they took the $2 million, they developed the solution, they implemented it, introduced it in production, they actually started using it in production, and after that, they figured out, well, it's replying to 50 emails per day. It's working well, but it's responding to 50 emails. And he came to the guy who actually gave the $2 million and said, why did you pay $2 million for something that actually you can hire a person that is actually doing it better and it's cheaper? Why actually have you spent so much money? And he said, well, now we can say, and it's true, that we use machine learning in our company. So, and this is actually what the buzzwords are about. Machine learning is now cool. When I came to my customers about 5 years ago and said, well, look, you need machine learning here introduced, and you also it will get you more money and so on. They said, well, no, we don't need it. It's something that we don't really need. But now it's the total opposite. Everyone want to use it: artificial intelligence, machine learning, deep learning, but not everyone really need it. And yeah, that's how actually it changed. That's good for me because I'm doing machine learning, so everyone wants to actually implement some machine learning, but it's not really so useful in many cases. But let's say you have a case where actually you need to use machine learning. Here actually are the two phases that are important when it comes to machine learning. It's the training phase and the prediction phase. Anyone actually did some machine learning work before? Anyone? Good for you. Okay, so around, let's say, 10 persons maybe here. So let's go through. I will explain that. So machine learning is actually working. We can divide it into two sections. The first section is the training phase. Let's go back to the example of skin cancer, right? So I have a mole. I have a mole on my skin. I take a picture of it, right? And I can take thousands of pictures of, everyone has a mole, and take a picture. And let's say I have 1,000 of pictures, and the doctor, the dermatologist, will take a look on the picture and say, oh, this is a cancer, that's not a cancer, right? It's a binary classification, cancer, not cancer. Most of the people doesn't have cancer, right? But some, unfortunately, have. And the case here is that the information, if it's this or that, are the labels here on the graph. The images are the data. So in machine learning, we are extracting the data because, well, for the computers, right, it needs to be shown as kind of numbers, right, to do the calculation. So we need to actually get from the images, so for the data, extract some features. So if you have a mole, we can get if it's how many colors we have, how big it is, if it's let's say. Yeah, you have the scale like color, diameter. You have the border. If the shape of the border is smooth or not, for example. This is something that can be a feature, and we are extracting the features to our feature vector, combining it together with labels. We use some machine learning method, and a machine learning method can be we have actually shallow methods and deep learning methods. Now you probably heard a lot about deep learning methods, right? There's such a rumor about deep learning, how deep learning will kill machine learning, and so on and so on. This is totally not true. Deep learning is a part of machine learning. That's one thing. And second thing, well, deep learning is just a neural network. Anyone heard about a neural network? Yeah, obviously. I will show you an example later. how does it look like. And so the methods here are machine learning methods. It can be deep learning method. It can be a decision tree. Anything. And we actually, in this method, we actually training. What means training? Training, at the end, in most cases, it's just setting the weights. So to setting you have a huge matrix, and you are setting the numbers there, right? That's it. It's a heavy computation usually. It takes a lot of time, but it's just setting the numbers in a huge matrix at the end. So it's quite actually easy. And then we have the prediction phase, which is the easier part. Easier, it means we get the data. We don't have the labels because we are predicting if it's cancer or not. Then we do the same actually process like feature extraction, building the feature vector, and then using the trained classifier, so the model, and use it to get the prediction, so get the label, right? So we're putting an image and getting the information, just replacing the doctor in this case. Obviously, it will not really happen like that. I mean, you probably heard about that machine learning will, make the drivers, taxi drivers, job. I mean, they lose the job, right? It's not really so true, to be honest. Okay. So, data preparation. We are cooperating with our hedge fund from New York, a company. It's quite big. That they are investing money in the stock market, right? And let's imagine that you need to develop an algorithm that is predicting if the index, the stock, will go up or down, right? Because this is how actually you can earn money in the finance. And, well, the data that is coming that you can actually grab, there is a lot of data. We can actually get the headlines from the newspapers. We can get the data obviously from the stock market. We can get the data, let's say, satellite images as well to get the information. How good is the company going? And it's a lot of data that we need to clean up before we actually get the value from it, because not every data is really valuable. And actually to do that, one of the things is actually our data frames. Anyone used data frames before? Yeah, cool. That's good. So it's good that I'm talking about that today. So data frame, let's imagine it's how to say it properly, it's kind of an Excel or kind of a table, let's say. It's not an SQL, it's not a relational database, it's just one table where actually you can put some data in it and easily do some work on it. It can be, the values can be in number values, I mean floating numbers, integers, it can be strings, actually anything you can put in. And when it comes to Python, you have pandas. Pandas is they are the market leader. It's obviously our open source tool, pandas. And you know what they tell about JavaScript, that every week you have a new library, right, on the market available. And yeah, obviously there is a version pandas for JavaScript, which is not really good, but there is one. And there are actually also different libraries like DataFrame.js, Recline, DataForge.js that are used to actually, you can use data frames for that. And here's actually an example. Here you have series and data frame. There's a series, I just put some numbers. And it looks like that. Not easy to read, right? This is how the pandas is doing it. But you can actually do it, move it to JSON, like here. Okay, here's another example. This one is the data frame. Series is just a row or just a column of the data frame, right? And data frame is the whole Excel, the whole table. And here you have a data frame with indexes. You can add indexes, so I have 2 because we have 2 columns, and you can actually manipulate the data based on the indexes. So that's quite easy. And you can actually also move it to our JSON, which is actually a good thing because you are. It's easy actually to do any kind of work on that. I mean, it's visually. It's the first thing, and second, you can actually use it in some visual tools in JavaScript, where actually we have so many actually tools for that in JavaScript. It's hard to beat that actually, even by Python. And also you have the string, which doesn't look pretty, but it's still a string. You can actually build a new kind of a table from it. Just to be clear, I'm not here to say that JavaScript is bad on machine learning. That's not my case. I mean, it's not the goal. I want to show where we are, right, and what needs to be done still. So the main thing here is to do some data manipulation. What means we should actually, like here, we can filter the data. So we can have a huge data, because it's not about, just gave example. I have example of actually 3 rows, right? But usually data frame is huge. I mean, they can get megabytes or gigabytes of data or pure text in it, and you can easily manipulate on that. So it's really what actually is the purpose of data frames. And you can actually get for example the row and then greater than 1 and move it to JSON, and here is actually the result. So we can actually filter that, and obviously we can also do it, move it to JSON. The limitations of pandas for JavaScript is, well, if you go to the documentation, there are still some methods that are not available for many reasons. Probably, not many people actually are contributing to this project because machine learning is not so popular for JavaScript as it is for Python. So it's still a lot of work to do. Just to give an example, here's how you do a multiplication of 2 data frames. And yeah, as you see, it takes about, it's just now, right? It's nothing to do the multiplication. You cannot multiply in pandas and JavaScript yet, but it will change. I mean, you can in series, but you cannot do it in data frames. But it's good actually in Python is that you can actually do also some plotting directly on the data frame. But in JavaScript, you have so many actually. I just mentioned 3, but you have, you are JavaScript developers. You have many of JavaScript libraries for visualization, and much more than Python. And you can actually use the JSON to export it to JSON to actually to visualize the data. Okay, cool. Any questions so far? Okay, great. Why I mentioned about data frames? It's as I mentioned, the company, the hedge fund from New York, they are even if they are increasing, even if they get around 1% increase in the accuracy, they just became millionaires. Because just the 1% on the classification, if it's going up or down, it's a lot of money that they are earning. This is actually how important it is to actually get valuable data from the noise that is actually outside on the market. So that's the thing. Here, okay. So scikit. This is a really short section. I tried actually to do some give here an example on that, but it's. Anyone heard about scikit? Scikit-learn? 1 person, 2 persons? Great. 3? Cool. Well, in Python, if you do some machine learning, you start with scikit-learn. It's a huge library with almost every shallow method available. I should have it somewhere here. Yeah, this is just another example of a linear regression. You have it implemented already. You need to build anything else. Just use the linear regression classifier, and that's it. So it's very, very, very easy to use. Just few line of code, and that's it. That's cool. That's cool. And it is ported to JavaScript. It was ported to JavaScript. Unfortunately, the newest version of scikit-learn was updated about a year ago, and the other one 5 years ago. So it's quite old, and there are not so many methods actually implemented. So it's not a good thing actually to use scikit-learn in JavaScript. But if you can or know Python, I recommend you to start also trying it out, because it's really there are so many methods that actually you can use here, and it's really easy to do. You see here you have decision trees, and it's a decision tree implementation takes like this one, so it's nothing when it comes to the line of code, right? And we have data sets, which is also a cool thing. If you are new on machine learning, it's also good to have some data sets actually you can use for training. And scikit-learn already provide this kind of data. Okay, go and get back to the JavaScript part. And actually, yeah, just going to scikit again. As you see, there are so many methods here: regression method, clustering, classification, many actually. When I did my PhD, scikit wasn't really available, so I wrote it from scratch. In Java at that time, but it was many years ago. So okay, TensorFlow. Anyone heard about TensorFlow? Sure you do. Anyone use TensorFlow? Okay, not 3 of you. Oh, that's good. So TensorFlow is like blockchain. TensorFlow, blockchain. It means, it's meaningful, right? So you have a flow and you have tensors. Tensors are these here. The purple, the orange one, the blue one here. These are the tensors. And the flow are the lines between each node here. So this is TensorFlow, right? Like blockchain and blocks and chain. It's the same. And we have, and tensors actually are nothing else like matrices. So tensors are smart matrices. It can be vectors as well, but let's say a vector is a special case of a matrix. But let's say you have matrices, and anyone know what kind of a function we have here? Any thoughts? What's the function called? It's a linear function. You use it on every day. You use this function. Actually, it's quite old. It's used in finance for many years. It's a linear regression. It's a linear regression where actually y is actually b multiplied by x plus w. Actually, no. I'm sorry, I did a mistake. W should be here, so we should replace b with w. My fault. That should be different. So this is actually a linear regression function, and we have different type of tensors. We have variables, we have constants, and we have operations, ops. The purple ones are the ops, so what kind of operation we are doing on the tensors, and the orange one can be variables, can be constants. So they have some value. Where actually the value, a variable can change, so the value is just kind of there was nothing in it, and the value actually are filled out after the calculation is done. And the operations are just saying what kind of operation needs to be done here. And yeah, here you have all the descriptions. You have placeholders where actually you can put the value. So actually, this is a model. It's a linear function. To be honest, every model is a function. Every machine learning model at the end is a function, mathematical function. Anyone studied mathematics? Yeah. So it's at the end it's a function where actually you multiply or do some operation matrices. And as you know, doing the operation matrices it's heavy. I mean, the computation can be heavy, especially if the matrices are quite big and you have to looping over and over again. But not in a linear regression. It's quite simple because you have actually one matrix here. I mean 3, but actually one that is changing is the weight matrix. Here's actually how we actually use. Just ignore the warning for now. Here's actually how we actually import the TensorFlow, and here's actually an example where I have constants, right, and do a multiplication of both matrices. It's an easy thing. Okay, cool. So this is how actually TensorFlow looks like. I know JavaScript is missing here. I know. I haven't done it. It's not by purpose. I just forgot about it. Yeah, I know. But it's just because JavaScript is not so often actually used to do that, and it's quite new. TensorFlow for JavaScript is quite new, and when I did this picture, it was a couple of months ago or years ago, and this is why. So on the bottom, you have actually just the TensorFlow kernel. Then you have the low-level programming APIs, like Python is the main language. Obviously, they have all different languages. Now we have JavaScript as well. And I know that they are also trying to do it with Swift, if they haven't done it yet, and actually many other languages. So it's not TensorFlow is actually the main library that is currently used for machine learning. Then you have the data sets, matrices, layers. I will say a few words about layers later when we actually go to the topic of keras. And you have the estimators and the rest of the things on the high level. Okay, so I showed you an example of a linear regression. It looks like here. And in TensorFlow, we can do it like the following. I just put some random data here. Just some random data and x and y. So you have two x's, x and y, right? And you have data on the x and on the y. And you have a linear function which say, okay, if you have x here, then you have the value of y is here. So that's all about linear regression. Yeah, we put some random numbers here to a and b. Ax plus b, obviously. Then the prediction is just multiply and add b. Ax, here you see ax, so a multiplied by x plus b. That's the whole thing. That's the prediction, right? But we need to train first before you predict. We need to train the method. So you have the training method here in the bottom. And the training method is actually nothing else like minimizing the loss function. Loss function is actually, we are dividing the values that we have and the predicted values. And we need to make the difference smaller and smaller. So actually, if you take a mathematical function, it looks like that. Here we go. At some point, it will go up, probably. And we need to find exactly the point where actually we are at the minimum. So we need to minimize this function to get the best value, the best prediction. This is how machine learning works. It's nothing else than math behind it. So you have some functions here, some functions there. This one needs to be minimized, this needs to be maximized. Here you have two functions that you need to solve, like you have one function that depends on the other function, like in SVM, for example, where you use it's called Lagrange Multipliers. Anyone heard about it? Yeah, that's good. You heard about it? Lagrange multipliers, yeah. It's actually for optimizing, because it's in SVM it's done in a bit different way. You have many constraints, and then depend on other constraints, and this is how actually it's used to actually optimize the calculation of the function, of many functions actually. But I don't want to go to SVM and many complex things. Maybe if you like this presentation, I can come next year and do some advanced TensorFlow with some more complex stuff. But for now, let's stuck on the linear regression. So this is how actually to train. There are a few things. The optimizers, gradient descent. So do you know what a gradient is? It's also a math topic. It's saying if we are going fast or in which direction actually the function is. Is it going here or there, or in which direction is it going down or up, and how fast it is going up and down. It's important actually to get to know that, because if we are going fast down, then it's cool. I mean, it's cool until some point, because at some point we can overfit and go on the other side of the function and go up again. So it's important actually that we are going in the direction to go low. And the learning rate, this is a fixed value that is used how fast we are going down, how fast we would like to go in the function. So that's more or less that. So it is a loop, just a loop. And here we have the training, so we are invoking the train function, and then let's say we have 2, and where we have the value for 2, we have 2.4. But obviously we can change it. I don't know, let's say 2.5. Oops. So it's 2.83 because it's a function, right? So it's the y, the x is 2.5, and the y is 2.83. I know, it's just a linear function, it's quite easy. And when it comes to Python, TensorFlow looks like this. Okay, in this case actually I use the MNIST database, which is use some images. It's downloading here. Here's the whole implementation of a linear regression. It's a bit different than the previous one, but more or less it's very similar. Okay, cool. Okay, so Keras. Anyone know what this architecture is? What kind of neural network it is? It's a neural network, good. But what kind of a neural network architecture it is? Autoencoders, exactly. Exactly. Good one. Yeah, autoencoders. Because we have encoder and the decoder. Well, how actually neural networks, because before I talk about a linear regression, which is just a line, a function, linear function. Here it's a bit more complex. Let's imagine you have such a linear regression in each node. Here, each of the blue, each of the purple, each of the orange. Let's say for now, and you don't have 4 nodes, but you have, let's say, 1,000 or 10,000, and you need to do the whole calculation on the 10,000 here, then on 10,000 there, and so on and so on. It's a lot of work that needs to be done, right? It's a heavy computation. Actually, this image, because I'm actually also doing some trainings for O'Reilly, and this is actually an image that I prepared for the chatbots. Why? Because autoencoders are used to generate some information, some new information. Oh, let's imagine in a different way. You know zip, how a zip works, right? You mean the compressing algorithm. So let's imagine you have some data here that is in the input. You are zipping it somehow, and it's the orange, and then you're unzipping it at the end. But you're adding some noise in it to get some new value from it. So the unzipped version is always different, if you know what I mean, right? Why is it used for chatbots? Intelligent chatbots takes a lot of data in the input, generate a feature vector. I mean, in the case of autoencoder, because you have different architectures, and at the end we would like the chatbot to respond differently every time, but intelligent, right? So we are actually putting a lot of data here, and get every time some different answer, but this is logically. I mean, there's a logic in it. The English is good, I mean the grammar is good, and so on and so on. So you can actually use this one. But why I'm saying about that is that neural networks, this one is quite complex because it's usually used as a deep learning method. because there are many layers in it. But each row here is a separate layer. It's a totally separate layer in a neural network, right? So you have the input layer, then you have the encoder layer, then you have the hidden encoder layer, then you have the feature vector layer, hidden layer of the decoder, the decoder layer, and the output layer. So 1, 2, 3, 4, 5, 6, 7 layers. In 2000, let's say 2 or 3, until 2006, it was very hard to do that, to build actually this kind of architecture. For a few reasons. There was no idea how to solve because there's a lot of computation here. How to actually make it working properly, not to overfit. And in 2006, Geoffrey Hinton, a guy from Montreal in Canada, he figured out how to do that. And on the other hand, we have GPUs, right? Everyone has one, I guess. Some of you playing games from time to time. And well, what is actually, just imagine, let's say, what's now the coolest game? I'm playing games. What is the coolest game currently? Let's say anything like Call of Duty or something. And just playing a game is actually nothing else. The textures that you have on your screen is nothing else as multiplying matrices. Multiplying matrices, doing some operational matrices all the time. And the GPUs are good on it. They are actually prepared to do operations on matrices well. And we have a good GPUs currently. So this kind of computation can be done easily, especially if you can actually divide it into many nodes as well. So this is actually how it works. And in JavaScript, JavaScript actually supports GPU. You know WebGL? For sure, you know. Yeah. So I remember when actually where WebGL started. I was playing Quake 2 on the web browser. It was, the FPS was like about, 15 or something, because all the calculation was done by the CPU, right? And then it was improved, and then at the end they actually moved the calculation from the CPU. Just because they changed from CPU to GPU, it started to be, it started to be smooth. I mean, the FPS actually increased to 60, let's say, and you were able actually to play Quake 2. I know some of you probably don't remember this game. It was a good, one of the coolest games on my age when I was in high school. But it started to work smoothly in the web browser. And this is actually how is actually working. I mean, how the deep learning, the neural network are working now. Generally speaking, machine learning, because it's all about matrices and calculation of matrices. And okay, Keras. I'm pretty sure most of you doesn't know Keras. Keras is it's not a library; it's a framework for machine learning. Obviously developed in Python, but you have a port in JavaScript as well. And it is used for building neural networks, but not as I showed you as in TensorFlow. Actually, you can take tensors and connect with the tensors together. You are taking the whole layers and connecting the layers with each other. Why? Because it's faster. Right? It's easier to do it in this way. So you have layers that actually connect, and at the end you get the whole neural network, and you can actually use it in the same way like TensorFlow. But actually, it's in Keras. Behind it, you have TensorFlow. So Keras use TensorFlow. It's like TensorFlow and Keras is actually a higher level TensorFlow at the end. I will show you that in a minute why it is like that. Okay, so let's go to Python a bit here for a minute. This is actually how it looks like. So you have different layers, like dense layers, dropout layers, and so on. You have sequential models, you have different kind of models, you have different optimizers. I don't want to explain all of these because it takes a lot of time. And as you can see here, I'm just taking the NIST database here, dividing it into the training set and the test set. Oh, I forgot about mention about that. Okay, so we have training set and a test set. What's the difference? The training set we are using to train the model, and testing set, well, what can it be for? Obviously for testing the training set. So not the testing set, but to test the model if it's working well. Let's imagine one thing. We have 1,000 images that we are using for training. We cannot use the same data set for testing because the model is already trained on this kind of data, so the accuracy will be super high, right? Usually, it will not be 100% usually, but it will be super high, like 90 few percent usually. It doesn't make much sense because it doesn't say us if it's really good, because the goal of machine learning is to actually build a model that generalizes well. It means it can be used for any kind of case, any kind of image, let's say. I still have time, right? Okay. And yeah, this is why we use testing set. This is totally different from the training set, just to test what kind of accuracy I get on the testing set. It is good just to not to figure out if we overfit. For example, overfitting means on the function, right? If you don't find the minimum, but go somewhere else. Or if we actually fit too much. I mean, if we just classify well the data that is only in the training set, then it means that we are overfitting. So this is actually how Keras can be built. How Keras can be used. Here, reshaping. As you see, you have a matrix of 60,000 here and 784 here. It's you have some data here, right? And the other one is 10,000. So it's a lot of data here. Here we go. So here's actually how we actually build the model. Here's actually how to actually move it from text to numbers. And so we have dense layer, you have a dropout, dense dropout, and so on and so on. So you have the activation function. Activation function is it takes the data at the end and say, okay, should it be this value or that value, like cancer or not cancer? Because each node actually do some kind of a mini classification in it, and you have many of them. And more or less, this is how it is working. In JavaScript, this is Python again. In JavaScript, you actually can run Keras models. You cannot build it, not yet, but you can run it. So still, you need to. In TensorFlow, you can build it. That's really cool, and it's actually for now. I guess this is this is the only tool that I would say can be really used for machine learning in JavaScript. There are a few libraries, like some specific libraries for decision trees, for linear regression, and so on, but they are separate. I mean, there are small ones specifically for a model. And in case of Keras, you are actually able to execute it. Execute the model, so use it for prediction. One thing that I forgot to mention, here you have a TensorFlow example. I'm saving it as a minist_archive.js.pb. It's protobuf. I'll show you what's that. Not here. Here we go. See that? It's a JSON representation of the model. And TensorFlow and Keras use it. So we can actually build an architecture in TensorFlow and use it in Keras. The opposite way, it doesn't work so well, but it's working well in the way from TensorFlow to Keras. So as you see here, it is quite long, the definition here. I'm still here at the beginning, right? So it's really huge one. And when it comes to the usage, it's quite easy, simple. Just a file path. This is actually how we actually load the model, and you are ready for the prediction. So it's a bin file. It's a HDF5 file actually at the end that we're exporting here. Here we go. You can also do it as a JSON as well. And this is how actually you can load the model into Keras. I still have a few minutes. So just to summarize, from my point of view, JavaScript is a good language that can be used for machine learning, but for now only in TensorFlow. The community is growing when it comes to the build, actually supporting, contributing to the libraries that are actually doing some machine learning. It can be easily used for prediction, like the example with Keras, and it supports the GPU. So there are many actually blog posts. They are saying, oh, use your machine learning, build your machine learning model with your browser. Not really. I would do it first of all in Node.js, just in back, and then use the model as a prediction in the browser. And obviously JavaScript is not the first choice for machine learning, but you are JavaScript developers, so you don't want to switch to anything else, and you would like to use it. So again, I would recommend TensorFlow. And there is still a lot of work to do in this area. I will show you one example if I have internet connection. I don't have. Okay, I did a presentation some time ago about Ruby and machine learning, just to compare. You know what is the good thing? They are way behind. Way behind JavaScript. They have. I was once on a meetup regarding Ruby, and there was one person actually talking about machine learning in Ruby. So to talk about machine learning, how they did in Ruby, what they solved, and so on and so on. And at the end there was a question. Okay, so what did you use to actually solve your machine learning problem? And he told something, blah, 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 blah. He actually didn't answer the question. So again, the person asked the question, so what framework, what library did you use for solving this problem? So finally he answered Python. And as you know, Ruby and Python are like the dark side and in Star Wars. They don't like each other, and they are really behind that. They have some libraries that are quite fine, but especially with the data frame, this is something that is implemented properly. But you have it already in JavaScript. When it comes to TensorFlow, it's worse, much worse, because you don't have. You have a nice implementation in JavaScript that is working well. You can start from now, and it's working really well. Well, it's stable. And in Ruby, there was a library called PyCall, which means call Python from Ruby. And this is how TensorFlow is built from Ruby. So in JavaScript, it's it is written very well. Okay, I still have some minutes. So. You can actually reach me if you have any questions. You can ask now, or you can actually drop me an email, call me, or find me on some O'Reilly trainings. Here we go, for example. This one actually was in July, but they are actually occurring. The last one was about 3 weeks ago from now, and there will be another one next month. So you can join me and listen how actually I'm building chatbots with Python. I cannot say it for sure, but there are some rumors. I will also have a training about machine learning and JavaScript, 3 hours workshop. But I can let you know whenever it is already announced. For now, it's not yet. So for now, I guess thank you. And if you have any questions, you can also find me after the speech. Get some beer or coffee and talk about machine learning. Thank you.
Thank you. That was great. And by the way, we do have the Slido set up for all the questions, so you can go to slido.do, search for KHJS, and put questions in there. And actually, like the top voted questions that we are going to ask out loud are going to be rewarded with a T-shirt. Kharkiv.js, we have both women and men types available. So, and we have few. And actually, like top questions that were coming in were regarding performance. So one is like how much slower JavaScript is compared to Python.
It's a good question. If you read some blog posts, you can agree that, well, this language or that language is slower than other language in machine learning. Yes, that's true. There are some differences, but for now, in the current state, it doesn't really matter because we are all using the GPUs. So at the end, the language doesn't matter for now. We are using the GPUs, so it doesn't matter if you do it from Python, JavaScript, Ruby, or any different language. You're just putting it to the GPU. That's it. So the performance is not the case anymore.
Well, and other than performance, the second question was about float precision, and based that JavaScript is not that well with floats, is it affecting in the end the end result?
Yes, that's a thing, but I think it's a myth. It's not really a big thing. You know, Python has a similar issue, I would say.
Yeah, sure.
So it's not really the case. It's also a common question.
Okay, yeah, and once again, there is a speaker corner on the first floor. If you go downstairs. Thank you. Downstairs, and to right across, there is a small balcony where we have speaker corner, and we invite you to go there after your talk, getting coffee or something, and go in there. There will be a moderator, and all other questions that you have left, you can ask Karol in there. And let's give a round of applause for Karol.